Machine Learning Programming Assignment. So my name is Kuridi by SB and my colleague is HRL Pereira. So in order to proceed with our assignment, we have been selected a dataset which is available on this link. So we have selected kaggle.com in order to find a dataset in order to continue our research. So I will show you how did I obtain that dataset now. So we can go to the kaggle.com like this. So from here we will be typing as diabetes. From here we will be getting different search results. From that we will be selecting the diabetes dataset which has been uploaded 5 years ago by this person called John. So from here we can download this dataset. Right, again we'll go back to the presentation. Right, so in here we have selected two types of tools, Anaconda Navigator and Jupyter Notebook. Anaconda Navigator is a graphical user interface that comes bundled with the Anaconda distribution. Anaconda is a popular Python distribution which includes many scientific and data science libraries and tools, making it easy to set up and manage Python environments for data analysis, machine learning, and scientific computing. Anaconda Navigator provides a user-friendly interface for managing Python environments, packages, and applications. Right, when it comes to Jupyter Notebook is an open-source web application that allows you to create and share documents containing live code, equations, visualization, and narrative text. It's a popular choice for interactive data analysis, research, and prototyping in various fields, including data science, machine learning, and scientific research. So if mentioned about some key features of Jupyter Notebook, it includes interactive computing, rich output, which means user can generate and display plots, charts, tables, and multimedia content within your notebook, enhancing the communication of our analysis. Right, so those things are small introduction about the tools that we have used within this assignment. Right, now again I will be moving to the dataset that we have selected. So by using this given dataset, we can determine when attributes such like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, age kind of attributes are available. Is there any possibility to make a prediction whether a patient is having a chance to get diabetes condition or not? In here, we will be dividing this dataset into two sets as training and testing dataset, and will be looking for the accuracy level. What kind of factors may involve highly in getting diabetes condition by making a machine learning model? In order to do this experiment, so as we have explained earlier, we are going to deal with two types of tools called Anaconda Navigator and Jupyter Notebook. Right, now I will be giving you an introduction about what kind of a machine learning model we have selected in here. Right, so in order to proceed with our assignment, we have selected supervised learning as our machine learning model. So in here we have selected supervised learning because of some certain features which will be matching with our dataset and our scenario. Label data. In supervised learning, we will be getting a label dataset, meaning that each data point in the dataset is associated with a target or outcome variable. In our case, the dataset is likely contains information about diabetes, and we can assume that we have labeled data where each entry corresponds to patient and includes information about whether they have diabetes. Predictive task. The goal of this task seems to be predictive in nature. We want to predict whether a patient has diabetes or not based on various features or attributes, example glucose level, blood pressure, age, and etc. This aligns with the typical use case of supervised learning, where we aim to predict an outcome variable based on input features. Evaluating model performance. In supervised learning, we can evaluate the performance of our model using metrics such as accuracy, precision, recall, F1 score, and ROC, AUC, depending on the nature of the problem, classification or regression like that. These metrics allow us to assess how well our model is doing in making predictions. Availability of historical data. It is implied that we have historical data where we know the outcome, diabetes status, for a set of patients. This historical data can be used for training and evaluating our supervised learning model. Because of these features, we have been decided to proceed with the supervised learning as our machine learning model. Right. So as the next step, we will be talking about which type of learning algorithms we have chosen which are coming under supervised learning model. In here, we have been working with two types of learning algorithms called gradient boosting classifier and random forest classifier. Right. Gradient boosting classifier is a machine learning algorithm that falls under the ensemble learning category. It's a powerful and versatile method used for both classification and regression tasks. Gradient boosting builds a strong predictive model by combining the predictions of multiple weaker models, typically decision trees. It iteratively corrects the errors made by the previous models and improves the model's accuracy over time. Gradient boosting is an ensemble learning technique similar to the random forest classifier. It combines multiple decision trees to create a strong learner. Each tree is built sequentially, with each new tree focusing on correcting the errors made by the previous ones. Right. So now let's have a look on random forest classifier. Right. Random forest classifier. Random forest classifier is a supervised machine learning algorithm which falls under the ensemble learning category. It's particularly useful for classification tasks, like the one we mentioned, where we want to predict whether a patient has diabetes or not based on various features or attributes. It's an ensemble learning method. It works by combining the predictions from multiple decision trees to make a final prediction. In our case study, we have data with various features, glucose levels, blood pressure, age, and etc., and want to classify patients as having diabetes or not. A random forest can aggregate the decisions of multiple decision trees to improve prediction accuracy and reduce the risk of overfitting. Right. So now we have discussed about which type of a dataset we are going to deal with in this scenario and which kind of a learning model we are going to apply here and what are the two algorithms we are going to apply which is coming under supervised learning model. Now we will have a look on how to load this dataset within Anaconda Navigator, and after that how to import the relevant libraries. So now I will be demonstrating that one. Right. So once after open up the Anaconda Navigator, in here I will launch the Jupyter Notebook. Right. So in here we can see that downloaded the dataset is available as diabetes.csv. So I will be taking a new terminal from here. Right. So first of all, I will be loading some relevant important libraries. Import numpy as np. I will run this one. Import pandas as pd. Import matplotlib splt. Then I will be declaring a variable as diabetes dataset. Right. Now I will give a small introduction about which type of libraries I have imported here and the purpose of using them. The first one, import numpy as np. So generally this line imports the numpy library and aliases it as np. Numpy is a fundamental library for numerical operations in Python, and it's commonly used for working with arrays and mathematical operations. Second one, import pandas as pd. The line imports the pandas library and aliases it as pd. Pandas is a powerful library for the data manipulation and analysis, often used to work with structured data in the form of data frames. import matplotlib.pyplot as plt. Matplot is a popular library for creating data visualization and plots. Import sklearn.matrix as sm. So this line imports the scikit-learn libraries matrix submodule and aliases it as sm. Scikit-learn is a widely used machine learning library, and its matrix submodule provides function for evaluating the performance of machine learning models. And the final one, %matplotlib inline. This is a Jupyter Notebook magic command that ensures that matplotlib plots are displayed directly within the notebook. Right. So after that, I will be loading the dataset, diabetes dataset, by using diabetes dataset equal pd.read_csv, and within brackets as a parameter, the CSV file name has been indicated here. So once after the variable name has been mentioned, you can see the dataset has been loaded to the Jupyter Notebook. Right. From this point onwards, to continue furthermore in this assignment, by using this dataset to make some prediction by using earlier mentioned algorithms called gradient boosting classifier and random forest classifier, I will be handing over the presentation to continue to my colleague Ranvi.
Thank you, Deshan. We have built two machine learning models that can predict diabetics outcomes with a high accuracy rate. So the first model, we have used a random forest classifier algorithm to predict the diabetics. So first we import our dataset, which contain various health related attributes. Then we handle missing values by imputing them with the mean of their representative column to ensure that we work with clean and complete data. Next, we divide the dataset into features and labels. Features represented the health attributes, and the label indicates whether an individual had diabetics or not. And also, we split our dataset into training and testing set to evaluate our model. Then we done feature scaling. Then we create and train the random forest classifier algorithm by configuring it with 100 decision trees, maximum depth of 18 and 17 features per tree. So with that, our model is trained and ready to make the predictions. But before that, we have to evaluate the performance of our models. Our model achieved an accuracy score of 98%, indicating it correctly predicts diabetics outcome in 98% of cases. And the precision score was 97.3, meaning that when our model predicts diabetics, it was correct 97.3% of all the times. And the recall score was 97.3%, indicating that our model successfully identified 97.3% of all actual diabetic cases. And the F1 score, the harmonic mean of perception and recall, was also 97.3. And we visualize our model's performance using confusion matrix as well. So as the summary, our diabetics prediction system using random forest classifier achieved an accuracy of 98% and showed a remarkable precision and recall value. And it is a powerful tool for early detection and control in diabetics case. Now, we'll show you the part of our code that allows you to input feature values and obtain prediction. In this part, we have created a function called predict diabetes, which allows you to input values for specific features that our model uses for make predictions. We initiate an empty list called feature values to store the value of your input. Then we define column variables, which is list of feature names we expect you to provide input for. We have used try-catch to handle user inputs, and then we call predict diabetics function to collect your inputs for the specific features. So after predicting the results, we check whether the model predicts a value of 1, which indicates that the person may have diabetics, or 0, which indicates that the person may not have diabetics. So we have provided you with an easy to understand message based on the model's prediction. Next, for the model 2, we use gradient boosting classifier algorithm to predict diabetics outcome with a higher accuracy. So similar to our first algorithm, import our dataset, which contains various health related attributes, and then we handle missing values to get clean data. Next, we divide the data into features and labels, and features represents the health attributes and labels indicate whether an individual had diabetics or not. And also, we split our dataset into training and testing sets to evaluate our model. And then we have done feature scaling. Then we create and train our gradient boosting classifier. We configured it with 100 estimators, a learning rate of 1 and the maximum depth of 1. So with that, our model is trained and ready to make predictions. But before that, we have to evaluate the performance of our model just as we did with the random forest classifier. So our model achieved an accuracy score of 83.25%, indicating it correctly predicts diabetics outcome in 83.25% of cases. The precision score was 80.92%, meaning that we have our model predicted diabetics, which was correct 80.92% of the time. And the recall score was 71.62%, indicating that our model successfully identified 71.62% of all actual diabetes cases. And the F1 score, the harmonic mean of precision and the recall, was 75.99%. Then we visualized our model's performance using confusion matrix as well. So, as a summary, our diabetics prediction system using gradient boosting classifier achieved an accuracy of 83.25% and showed a good prediction and recall values. While the accuracy was slightly lower than our previous model, it was still a powerful tool for early detection and control diabetes. Now we'll show you the parts of our code that allows you to input feature values to obtain the prediction. In this part, we have created a function called predict diabetics, which allows you to input values for specific features that our models use for. We initiate an empty list called feature values to store the values you input. Then we define the column variables, which is listed of the feature names we expect you to provide input for. And we have used try-catch to handle user inputs. And then we call the predict diabetics function to collect your input for the specific features. So after obtaining the prediction results, we check whether the model predicts a value of 1, which indicates that the person may have diabetics, or 0, which indicates that the person may not have diabetics. So we have provided you with an easy to understand message based on the model's prediction. And that's the end of our demonstration. Thank you.